Okay, we come now to our panel session, so I'd like all the speakers to come up to the stage, please. Okay, so I'll open the floor to some to questions of the speakers, and also the speakers here, the panel, are welcome to ask questions of the audience as well. I'm going to start with just one question, and then invite you. The first question is, there's often the comment that big data is really, and Tim mentioned this, the death of statistics. So would anybody like to comment on this?
Okay. Let's see. Okay, good. No. Yeah.
Oh, the next question.
That's right, yeah. I mean, the fundamental theorem of data is that the more data you get, the more elaborate model that you're going to fit, right? And so you never, if you have enough data that n is effectively infinity, then you're not fitting a sophisticated enough model, right? So, no.
Shouldn't it change? I'll hand it over there. I believe it should change the way statistics are taught. Because when I went through it and realized that I wasn't dealing with sample sets and I could take, non-parametric statistics because I was dealing with another set, and I had census, I went, aha, it was a very exciting moment, and realized that, but none of the statistics professors understood it because they'd never dealt with full census data. So in essence, the sets that you're working with could be considered almost full census data sets.
Yeah, I work a bit with machine learners, and they lay down, I think, quite a challenge to statisticians. And I agree about the census of data, but the census is never complete enough that it includes the future and things we don't know yet. And I think, speaking of death, we had two kinds of ancestors. We had ancestors who saw lines that weren't there. They're our ancestors, because the other kind of ancestors, the ones who didn't see the line that was there, they're gone. And as a result, I think as humans, we have a tendency, even when we become very cerebral, to see patterns that aren't there. And I think that's one of the contributions of statistics, is to try to bring some discipline to that.
Well, that's the false discovery thing, that basically when you've got a lot of data, everything can be, in some sense, can become significant, and I think statisticians have a big role to play in that. I think just because you've got a lot of data. Secondly, actually to second John, I think and looking at Rob's work, you don't have the data in the future, so that if you want to look at stock prices, if you want to look at what happens in the future, you still got to have models that do the prediction. I think also a lot of the data that we get is happenstance, and what we want to do is actually utilize modern technology to conduct online experiments, so that instead of revealed preference data, we've got stated preference data, so that we eliminate a lot of the confounding factors. Anyway, Rob, do you want to say something?
Yeah, I'd just like to say that I think this is the most exciting time to be doing statistics. We've got more data to handle than ever before. We've got better computing power than ever before. We've got some really interesting problems, and the whole world suddenly is interested in what we can say about the data. So far from thinking statistics is dead, I think this is probably the most exciting time that statistics has ever been in, and it's great to be part of it.
Okay, thanks, Rob. All right, I'm going to, oh, sorry, Thomas, did you want to say something?
I can only add, like the importance perhaps of visualization to the addition to statistics when you see visuals of your statistical modeling and so on. So we need to perhaps, somehow find new models, like visualize stuff and, connect dots together.
Okay, great. All right, so now a question from the floor. When you ask a question, please introduce yourself and where you're from, and any other thing you'd like to tell everybody about yourself. But no. So who would like to ask a question?
Hi, I'm Jason Jowett, an entrepreneur based in the Gold Coast. How soon do you think that it's viable that the government introduce with big data infrastructure, sociological based infrastructure? How soon do you think that it's viable that the government, rather than private enterprise, introduce the sociological-based infrastructure?
We're going to have, let me get my head straight here. The ANZLIC, the Australia-New Zealand Land Information System, is the spatial data layers that are agreed upon as a standard, which relates to Queensland Globe because it was falling under that, and they launched the national map a few months ago to match that. That process is to make all of the sociological data available. So it started, you have to stay actively involved and talk to them about that, of course, but there's a variety of meetings, and it's coming out of the communications Turnbull's division down in Canberra. So all the signals are good that it's happening. Queensland, New South Wales is jumping on the bandwagon, and it's an Australian federal-wide policy that's being implemented piece by piece.
Okay, next question. I think there was one up behind there.
Hi, my name is Nick. I'm a PhD student at QUT. So I have a question about this. So there's statistics, and people talk about data science as if it's a different animal, it's a different thing. And I was just wondering what your opinion on data science versus statistics is, and also where you think, what language should we be using right now? There's a lot of languages that were talked about today, R, Python, MATLAB. Is there, I'd be interested to hear if there's a consensus amongst the panel, perhaps.
As a fairly, I don't have the years of activity, perhaps, as some of the people up here. In my head, I would say that data science is a new, probably call it a buzzword, but it's just it's a way of communicating that data analysis still needs scientific intent and rigour, and I see statistics as not different to that, but as part of it. I know that some people probably want to say data science is other things other than model-based analysis. It's maybe machine learning and visualisation and other things, but from my perspective, the way I see it and the tools and so on, I think a data scientist, which I'd probably start thinking of myself as, actually is someone, the best data scientist is someone who can command multiple tools and learn how to apply them at the right time with the right understanding of what's good about them and what's not good about them, and so on. And that's actually kind of an art form, which I don't know if the others agree up here, but it takes quite a lot of time and a lot of trial and error and working out and learning and listening to try and think, when do I use the right tool from the tool bag, which is not that dissimilar to science in general. I guess now it's just that we've got a lot of tools, and so we have a big need for a good understanding of the tools at the right time.
So I work with a lot of people that I think of as data science people, data scientists, and they're not statisticians, right? I mean, stats has a role to play in data science in the sense that once you have data, modeling and kind of understanding, randomness and things like that are useful. But there was a reasonably well-known high-up, machine learning guru at Google. And he was talking about machine learning, and what do young people not understand about it was that, well, only about 5% of any machine learning project is the cool algorithmic part, right? What you and I, the modeling bit, right? The rest of it is data pipeline building, right? And there's just a lot of unsexy grunt work that goes along with that. And data scientists are really good at that stuff, man. They're what language should you know? You should know Hadoop, you should know Spark, you should know some of the stuff that Tomas was talking about earlier. Just the data munging is the kind of main thing that the data scientist brings to the table, and you don't do that in R, right? So what do you do it in? I mean, there's enough different sources of data that you have to know about. The data scientist looks at a problem and tries to figure out, where do I extract the data from I have to go get the weather in Singapore and the stock price in Peru, or where do you get all that stuff, right? So I mean, kind of knowing where to get the data from, being able to extract it, being able to kind of put it in a usable form, that's a lot different than Gaussian processes, right? So that to me, that's what the data science guys bring to the table, and being able to kind of just get data and tabulate it, make a scatter plot, make a histogram. That's data science guys can do a lot of useful stuff along those lines that has nothing to do with statistics. I'd like for stats to kind of get more into to a place where we can do some of those things, and then we can bring some of the advanced modeling to that game.
Steve, so I want to take you up on that and say, why call it science? I mean, what is it? I mean, data science conveys that, statistics is maybe mathematics combined with special statistical stuff, or statistics combined with some mathematics. But, I mean, what you're describing is, is somebody that is maybe a cross between a very good applied computer scientist, but it's not science. By giving it that sort of name, we give it a sort of a special status.
You want to take it first? Yeah, I see what you're saying, Rod, and I hear you, but there's a place in, I don't want to say modern science, because I think actually we've had these people all the time. There's a scientist who's a specialist generalist, and I would say that, and maybe you're going to make the same comment about, say, a complex system scientist or something, say, what the hell is that? Right? But actually, I think you don't want everyone in your department or your faculty to be these people, but you need a few people. I sometimes maybe call them kind of bees in the garden or something, pollinators, understanders who have understandings across different tools, and probably in the way that we just heard, it's like that in terms of it is actually, I use the word art, but I think there's science in the sense of understanding how to bring all of those tools together in the right place, in the right way, and with that, there's an emergent process where you actually get something. You're still testing hypotheses. You're still driving towards them. You've got a tool set and so on. Just because it's taken from diverse areas, I don't think that's any less synthesis than what someone does when they do other scientific endeavours. That's putting new things together in different ways that haven't been done before, and that's combinatorial, collaborative scientific work, which is what science is built on. And I think data science probably just tries to say that, well, we had a word which was like lots of observation, it was data. We don't have a really good way to describe the generalist, in a sense, who's able to put together all these tools and do something new and ask new questions and answer them with this kind of tool set. Let's call it data science. In the same way some people saw complex system science as science, and I'm sure there's people who don't like that either, but I think I would preserve a small place for the scientist who's able to go across all those things and work together. What that person has to do, maybe I'm starting to talk to myself here, is understand well what they don't know very well and work and collaborate well with people who do. So for me, that means our group working with Rob down the hall and saying, what would be the tools and techniques as a statistician that we should be looking at in this particular area? And then we have other conversations with other people in other groups and trying to get the best of all of these different areas. And then we've got to still do work of synthesis and putting that together to answer those questions. That's my small defence.
Just one thing to add to that is that statisticians, compared with a number of other disciplines, are used to working in teams. The consulting statistician working with a real scientist is a model a lot of us were brought up in. You have to learn it as a first-year student. Well, what I hear here, and I think what is demonstrably true, is, you know what? The team has just gotten a lot bigger. And you can fiddle around all you want to with the name, but a data scientist, machine learning, they're now part of this team, because we're not going to be able to use the information we have without having that kind of team. And plug, that's one of the reasons this whole center makes sense.
Thanks, John.
Yeah. I'd just like to follow up on that. I really think of data science as a generic term that deals with anybody who works with data who's a scientist, and that includes people that come out of computer science that are doing machine learning. It includes statisticians, it includes econometricians, it includes people who are specialists in managing large databases. I think we're all data scientists with different specialties. And we need a team of people with all the different specialties to be able to solve a lot of these problems.
Okay, so let me follow up then. I'd like just to go around across the line and ask you what's the single most important thing that a young data analyst in big data should know?
You go first. You go first. Let me think about this.
I don't know about the single most important thing, but let me put one thing on the list. They need to know how to code in some language so that they can script their analysis.
I would say that the standard kind of PhD mentality or psychology, which sometimes comes on unhappily, is still very relevant, which is don't believe what you see first up. So you need to have a healthy dose of skepticism. I think that's critical in data science work. You've got to look at the problem from different directions and understand errors and what's going on and how it aggregates, and really know what you don't know is important to major on.
Actually, I don't disagree with this, but I think that, first of all, I think statistics becomes incredibly important. Just one thing I didn't say was the idea when we have a lot of data, we've got endogeneity, so things affect each other. So when I think about what people should know, what's the single thing, and I agree that programming is important, I guess a good grasp of the relevant maths, because what's the hardest thing to actually pick up later on? Well, programming maybe a little bit, but actually understanding the relevant, and we've got lots of different kinds of mathematics now, from mixture models to various kinds of clustering to optimization. The thing that ties everything together, if you don't understand the maths, you can only go so far with the programming, you can only go so far with everything else. I think it's the maths that drives everything. It's the relevant kind of maths.
I think what's important as well is perhaps experimentation. So you have many different frameworks available, for instance, for doing big data processing. Just have some time, spend some time with different frameworks and see what's possible to be done and connect dots together, you know. Like in the old days, we could use C++ or assembly language, use assembly because it was faster, but is it for everybody? It's not, So pick up your, one of the best choices that works for you and just go with that. So that's perhaps one of the comments for the previous question as well.
I think, this is a bit of a dodge, but one of the things to be aware of is that the skills that are necessary to do good data science are vast, right? And I don't think anyone's going to be an expert at all of them, right? So it's a really collaborative type of thing. And so I think what's the most important thing to know depends on who you are. If you're coming from computer science, I think the most important additional thing to pick up is statistics, and vice versa. If you're coming from statistics, I think learning about some of the CS and machine learning world is helpful. So just kind of take whatever your field is and try to glom on to the other one.
Yeah, I just want to reinforce the points that both Robert and Steve made, because they certainly ring with my experience. One of the most fortunate things I had is I kind of decided toward the end of my undergraduate career what I wanted to do, and I had an advisor who said, don't go out and take that baby stats course, you know what you want to do, go take measure theory. And I did it just because he said so, and how right he was. It would have been so hard to get later on. The other thing is, I think apropos what Steve said, for a long time, and I don't know if they still do it, Stanford University had a rule in appointing their faculty that the appointment had to be joint. It had to be in statistics and something that, depending on your point of view, you might call a substantive discipline, and they did use that word. I think that's terribly important. Question I used to ask on master's and PhD exams was to have students sort out the difference between statistical and substantive significance, and they hated it. But I think it's something that we really need to know how to do.
Tim.
I was hoping you'd forget. One of the things I would recommend, of course, nobody programs in Unix anymore, so that's, that's a shame. Oh, good, good. See? Unix, learn that one. That's, yeah, but no one was saying it. I was like, yeah. So is systems theory and systems understanding, because there's a whole world out there, and I believe that that's very important. That means different things to different people, but it brings in the second point, is that you're not lost into your subsection. And secondly, is to come back and get a real connection with the world. You'd be surprised that the ivory tower and the august university environment is a protected bubble. So going out into industry and going out and finding out what they think about the tools, et cetera, is very important. Do an internship, get connected. That's a degaussing mechanism. It really helps you understand relevance outside of the university. So understanding the big picture systems, very important, and then getting connected somewhere with a reality, whether it's a brokerage firm you want to work with or a medical analytics firm. That can help you as you then hone your skills, because they've told you there's a lot of skills to develop, and then hopefully you're a good enough artist to pull it off.
Okay, thank you. Another question from the floor. There's a question. John. Thanks, Zoe. The next one has to be up that corner for Zoe to have to run all the way up there. Okay. Okay, we'll have John and then Miranda.
I'm sure if I was a sort of a Babylonian, whatever it was, chief, I'd be going, I've got all of this data on these clay things. What am I going to do with all of this data? So I suspect that big data's problems have probably been around for a long time. So my question is, why now? And it's sort of, so I'm interested to know, why now, and what sort of things do you think are going to be the next big thing in big data? And I'd also just like to ask the other side of that question, which I think the concerns around big data, which is around privacy. So where are we going, and what do you think about privacy?
I'll say something quickly, then let the others speak. For me, it seems fairly obvious that at least industry is going for personalisation, which Steve picked up. That's in health, that's in government, that's in commercial activity and so on. And we're all part of that because we're wearing devices, increasingly willingly wearing devices that's divulging all sorts of information and being happy with that. I'm not much into I'm not going to say much about privacy stuff, but I think that we're going to be looking more and more at that personalised world. And that has great opportunities for people who are interested in that, but I think that's probably going to even make more challenges because the observation level, I'm looking at IPs. That sounds personal, but actually it could be 5 or 6 users in a family using one IP, even at the family level. I have no idea about them. They're just silhouettes that turn on a computer or not. Imagine if I could observe content or demographics and so on. Maybe governments do that, but we don't yet.
Small thing on privacy. If you've got gray hairs, your perceptions are very different than others. Younger demographics, they don't care. I did not want to give up from the United States, Social Security number, and refuse to this date to anybody. So it means a different thing to a different generation, I believe. People are going to volunteer. So what's the next thing? I believe that we are going to use these to surround our world with our decision-making, health-making, and everything else. So these will become our own deities, in essence, because they will help guide our lives. Why? Because they will take the analysis from big data and take our perspective in it. So when I order a second order of chips, the thing will go off the chart and go, not with your cholesterol, big boy. So there's a lot of things like that that will be helpful, and I will accept it.
I think a lot of it has to do with it's just really easy to collect data right now. So why now? Well, we have the data. I think we were on the road to collecting a lot of data before we had the tools available to manage it. And so a decade or so ago, Sanjay Gemawat and Jeff Dean published the MapReduce paper. And that sort of said to the world, okay, here's a tool you can use to troll through all this data that you've been collecting to this point. And then Hadoop came on the scene, and we had Hadoop, and so that sort of let the rest of the world play in that space too. So, like a lot of things, why now? Well, it's because we have the tools now. You're asking what's coming next. I think that we've sort of been going through a progression where we have been able to kind of put a lot of resources to the data management problem. I think what's the current state of the art is the data modeling problem, and I think the future is the uncertainty around the model, which is still something that we don't have right, but I think that they're definitely going for, and it's a big important problem.
Yeah, I think the answer on why now is that the tools have changed. When I started out in my graduate career, a computer that had 128 kilobytes of memory cost in the millions of dollars. And in statistics, we had a way of dealing with big data. It said you need a model with a sufficient statistic. That was the best we could do. But opportunities have enlarged hugely for external reasons, and we need to keep up with that.
Okay, let's have Miranda's question.
Hello. I really wanted to thank Tim. I thought that was a very positive and enjoyable talk. Thank you. As a bit of a jack of all trades myself, I started out in agriculture, worked in development, worked in Queensland Treasury, and now I'm an academic teaching statistics at UQ. So I think it's very important that we have a broad perspective in statistics and data, and that we should be training the next generation coming through to appreciate that. Unfortunately, statistics is still seen as a bit of a subject that maybe isn't that important, but I try and change that. My question really is about the census. I understand that the ABS is considering maybe cutting back on the census, and I just wanted your points of view in terms of, isn't this just a time when we should be collecting more data? Because if we don't collect a wide range of things, then we end up, being a little bit biased or not collecting a good range of data. Maybe we'll be, not understanding things properly. Thank you.
I think we actually have some members of the ABS here. Yes? Are they still here? There's a finger being pointed. Yeah? Okay. Okay, would you like to respond to that, or are you happy for people in the panel to respond? This is not putting you on the spot, it's just asking, because we have expertise here, we may as well use it.
I think the only comment I can make is that I have no comment. So, yeah, our CEO has been quite public of late in terms of a number of positions that are being viewed by some as non-traditional and controversial, and of course, more data the better, but just like everybody, we're faced with budgetary constraints, and yeah, look, it's one position that may or may not eventuate, but yeah, that's...
Okay,
I can't really say anything more than that at this stage. It's all very much in the works at this stage, so...
Okay, thanks. The Bureau of Stats is a partner in the centre, so we're bound to hear more about that. Would anybody on the stage like to comment on it?
My understanding is that the budgetary constraints is one of the features of possibly the decision around it. I understand it costs over $400 million to run a census, so the question is 5 or 10 years. Probably an interesting question maybe to throw around is, we talked before, there was a question about the end of statistics, which I think I've got an emphatic no. But another question would be the end of census. So census is unusual when you do it like Australia does, because you get such comprehensive, go and find individual people wherever they are. I used to work in a homeless shelter, and census teams would come and we would work very hard with individuals to get them included in the census. Now, revealed data coming through devices and so on. Imagine if the government got streams of wearable data and so on and tried to somehow infer the kind of fields that come through the census. Just imagine down the future that those sort of fields start cropping up. Is it possible? What do you miss? What do you gain? Obviously, you could have a census happening weekly, daily, updating on what's going on in the state of the world. Do babies suddenly crop up and start having wearable devices placed on them? This is looking into the future, but I'm just wondering at what point our inferences about the Australian population from other sources is coming like this. The census is setting the gold standard, but at some sort of cost. Where's the gap, and does it ever meet?
Okay, thank you. Question? No. Okay.
There's a thing that this has just been on my mind, and maybe we're supposed to ask questions of you guys, right?
Yeah.
So here goes. Survey sampling, right? News stations do this all the time. You know, CNN in the States will poll its users and come up with some sort of number of what fraction of its viewers believe proposition A versus B. But this poll is not scientific, right? Well, we just got 3,000 people to answer a question on the phone or do something online, and so that's a number. The number didn't come from a sampling frame. It didn't come from any sort of a survey, as we professionally understand it. But it's information, and we ought to be able to use that information in some sort of a way, even though we know it's biased. I sort of feel like it's a failing of our field that we don't know how to take that number, which is not scientific, and do something useful with it. And I think that's one of the issues with the census, is that it's so expensive because it has to kind of meet these standards. And in the U.S. there's seats in Congress and things like that are going to be determined by it, and so it's really important that we get the right numbers. But if we could find some way to kind of bring survey sampling along into the internet era, then certainly we have the ability to do extremely unscientific surveys at much lower cost than we ever could before. So how do we do that? And if we can do that, then maybe we can bring the dream of the census, that Simon just described. Without that, I don't know how you give iPhones to the homeless population so that they can be tracked. But I mean, if we could solve the unscientific survey sampling problem, then that would go a long way.
I mean, there are two issues here. One is the non-scientific survey problem, and I think that's impossible. I mean, if it's bad science, it's bad science. You can't make a set of numbers good once you've collected them in a bad way. But the second thing is the important one, which is the census reaches remote communities and various other people that are not easily got at. But maybe we can do that at a much lower cost than is happening now. And I guess that's the ultimate question you're asking. Do we need to poll everybody in order to sort of get fundamental questions about money allocation for social services and other things, and even for the number of seats each area, in Parliament, each area gets. If we could do a much better job in just doing surveys scientifically, then I think that would be fantastic.
Okay, another question.
Thanks, Scott McLean. I mostly analyse market research data, and I was just Googled Google, actually. Well, I was very lucky because it says you've got, I shouldn't say you, Google has easy answers for every business decision, market research that's fast and accurate. Create a survey. This is the new online internet-y thing. To find out what people really think, just ask the internet, which kind of contradicts what, and I mean this in the nicest possible way, but it kind of contradicts what you were saying. So that's just a comment. The other comment I wanted to make was I watched Jeremy Howard's TED Talk last month, if you've seen that at all, where I'm pretty sure I'm paraphrasing him correctly, he says with machine learning, if you look at the 4 major Western economies, 80% of the occupations are in service industries. Those occupations will be gone in 10 years because of machine learning. I don't believe it, but the panel might like to comment on what they think about that sort of statement, if I paraphrased it correctly.
Let me take the first one, because you're talking about a product called Google Consumer Surveys, and that was exactly what I was thinking of when I was asking my question to the audience. And these things work a lot better. We don't understand why we're getting such good results out of Google Consumer Surveys, because there's...
Most of the data I analyse comes from those sort of surveys, so I don't have anything.
No. But Rob does. When it came time to predict the results of the last presidential election, Nate Silver was the rock star, and the big data source that Nate Silver said was his second most reliable of his 50 or 60 polls or whatever he was using was Google consumer surveys. So we have this method of conducting these, probably slightly better than CNN, but not certainly not gold standard surveys. And we can get respondents at 10 cents a respondent or something like that. Some very, very, very low number. We've had the Pew survey guys look at the stuff that we've come up with, and basically the Google Consumer Surveys survey results of a bunch of different questions that Pew came up with matched the Pew guys, right? So they ran their own thing. And so these things tend to work, and I can imagine that you could ask controversial questions that would break them. But if you're measuring public opinion about the new movie coming out or something like that, who do you think is going to win the Super Bowl? This is you're going to get basically the same sorts of results that you would get if you were to do the sampling frame and the type of stuff that we're all taught to do. So I find it odd that if we could get a very large number of people that we know nothing, and I know about Dewey defeats Truman and Langdon and all that kind of stuff, all the scare stories that we tell about what can go wrong in these things, but if you do something that can go wrong some of the time, it doesn't mean it's going to go wrong all of the time. And I don't know, there's just something there that I don't know how to put my finger on it, but we have information, and that information ought to feed into some sort of a Bayesian posterior. Given that I told you that this many people said this about about some proposition, that should update your belief about the truth of that proposition in some way. And I don't know what that way should be. So there's that. I'll let other people speak about the second part of your question.
Well, actually, I'm going to have to stop because we are over time. But I will leave it at there are questions that are unanswered, and I'm sure that people in the audience here also have answers and other questions. I think today has provided some of the answers and raised many questions. I'm sure that there's a lot of expertise in the audience as well that we can tap into, and I'm hoping that we can create some networks and further workshops through the centre to help us share the information amongst ourselves and others. So I'd like to thank very much the speakers for today. They've come from many different places and shared very different views on the issue of statistical modelling and analysis of big data. So to them, thank you. And to finish with the quote that I gave from Gerard Manley Hopkins, I saw this morning, morning's minions, here they are, kingdom of big data, and they dived into the big data and they produced gold vermilion. Thank you.